This tutorial covers looping with the Talend Data Mapper. We're going to have a look at some looping. So we've copied the examples project into an examples 1 project. And what we're going to do is go through all of the looping examples that are described in the loop cookbook. You can find the loop cookbook in the help, the Talend Data Mapper book. If you go to looping expressions, there are a number of looping examples in the looping cookbook for matching loops, nested loops, and so forth. So we're going to go through each of those examples right now. The first example is the simplest one, which is just a loop where the output corresponds to the input. So in this case, we have a purchase order we can look at, XML purchase order, with some line items, and we have this notices XML output, which we run, and it's also got items. And the way the mapping works is we have one notice element for every purchase order element. So if we click on the notice element, we see in the loop tab the use of the simple loop function, which is the basic loop, which says, the simple loop function says, make this output element loop according to some input map element. So here, this output element, which is notice, is looping according to the purchase order input map element, which is defined here. You can go to a map element by saying go to map element, and it will take you to that map element. So we can show, now this looping is actually automatically calculated as you map things. So what we'll do now is we'll remove all of the mapping and just build this up. Remove the mapping expressions. And we'll notice here there's no loop expression. So now if we map something, we see that it's mapped, and we see that it automatically generated this loop expression. So now, here's an example of a nested loop. If we want our items here to correspond to line items, we note that there's no loop expression here for items, and we map something here, and then we see that it is also automatically generated the loop expression. And when we run it, we can see the values that we've mapped. Okay, now we're going to show how to do sorting and filtering with the loop expression. So the loop expression controls under what circumstances output map elements are generated. And so it can control which input map element they refer to, and if any, and it also controls filtering and sorting. So in this case, what we want to do is try a sort. So let's look at the input here, and we'll try a sort by quantity. So we can see that the quantities are arranged in this order on the input. And we'll select the loop expression. And underneath we're now working with the functions tab. So this has all the functions that you can use. And the looping functions are defined in the looping category here. And then within there are the sort keys. So if we want an ascending sort, and then we can specify quantity. And now we can just run the items loop here. And we can see that it's correctly sorted on quantity, 1, 13, 1,500, and so forth. Now you may argue with this, saying these are not in numerical order, but these are in fact strings. So it is sorting the strings correctly. We can change this to a descending sort if you want, and see that it works the other way. Let's run the whole map, and we can see now the order is reversed, that the highest quantity numerically as a string is shown first. So now let's add a filter. So say we only want to have quantities that are less than 1,000. So we will use a filter expression, and we have to use a comparison in this case. So we will go to comparison and logical, and we want lesser. So we want the quantity is less than a constant value. We're dragging a constant here, We double click on that to put in the value of 1,000. Let's see what happens. So 1 and 100 are less than 1,000. Again, this is a string compare because these are strings and not numbers. So here we've showed how to do filtering and how to do sorting. Okay, now we're going to look at the next item in the loop cookbook, which is nested looping. So the previous one we looked at is where the input and the output looping corresponded. And here's now a case where we want to consider that the output looping is different than the input looping. And in this case, if we go to the example, in this case, we have a purchase order, and we have a different input structure. We're still using the same output structure. But the difference here is this input structure now has, it has 3 loops. So it has a purchase order loop, a delivery loop, and an item loop, whereas our output structure has a notice and an items loop. So the way this works is what we want to have happen is we want to have the looping for the notice to match the delivery loop. So here's what ends up happening in the loop expression is we have a simple loop here that corresponds to the outer part of it, the purchase order, and then within that we specify it using the context argument of the simple loop. We specify a nested context, which is another loop relating to delivery. So now let's show how to build this up with actually doing the mapping. So we'll get rid of all the mappings, and let's just do our mapping as we would expect. Just drag something from the input to the output. Now notice it has just automatically created a simple loop expression matching notice to the purchase order loop. Now let's map something here in the delivery loop, and we'll use the deliver to name. So here what's happening is it's offering to change the loop specification. It's saying that, okay, the current name is already looping using this output element, this input element, purchase orders, which is not compatible with the delivery loop. It doesn't know how to do that, but it can change it for you. So we'll say yes, go ahead and change it. And so now what it's done was it has automatically generated this loop expression by changing it. Now, so that just shows you how it's automatically created. Now we can also create it manually. So you can always, so the examples that we've shown so far have always automatically created loop expressions. But you can also just simply delete them or change them any way you want manually. And if a loop expression is already there, then the automatic loop creation will never override that. So this one shows a compound loop expression using a nested context, so that the output loop is considering a nested input loop. And if we look at this, we'll see we get one notice record for every delivery record. The second purchase order has 2 delivery records. Okay, now we're going to continue and look at a couple of other ways of handling looping. So one way is, suppose you have a situation where you want only a certain number of iterations of the loop to occur, and it's no relation to the input. So we'll play around with this a little bit with this items loop. Say we only want 1, which is a very typical case. So in that case, we use a different looping function. We use the fixed looping function. So we click on items, the loop tab, we drag fixed loop in here. The default is 1 time. Notice here it says fixed loop default 1 time, and then here it says number of times. This is something that you see in a lot of functions. So if we double click on the function, we see a count here, which allows you to specify a property of the function, in this case 1. And then you could also specify it as an argument to the function. So this basically handles the case where you want to specify it statically, which is most of the time you want to do it that way, or dynamically. This is covered in the help for the function, so you can go to the help of a function right inside by right-clicking help. And you see here it describes that there's a property called count, and there's an argument. So both the property and the argument are the same thing, and it's basically for convenience. So you could, if we didn't have the property, you could say number of times and specified a constant function of 1, and it would have exactly the same effect. But it's for to allow you to easily specify something that's a constant, or to specify it dynamically. So in this case, it's going to be emitted one time, and so here we can specify, for example, a constant. We can say map this to a constant, the item number, and specify like a value of 12 or whatever. And then if we run the map, we'll see the items loop occurs one time with this specific constant in it. Okay, now say what we want to do is map the, this is a contrived example, but we want to map something, this input number here, into the item number, but I'll have it only occur one time. So the obvious thing, I've removed the looping expression here. There's no more fixed loop here. So if we drag the number to the item number, it will map it. And if we look at the loop, it actually will generate a loop expression going up to the top of the document. And so if we run the map, we're going to see we get a notice for each PO, and then we also get a item number for each PO. So it's basically looping through the POs twice, which is not what we want. We only want one of them, and we want the number that corresponds to the PO. So how do you do that? Well, the easiest way to do that, let's remove the mappings, is to unroll the loop. So what you can do is if you right-click on a loop, you can say unroll from loop, and what it does is it creates in the map, it creates a new map element, which is has exactly the same children, except it's not a loop. So you can map it as if it were not a loop very easily. So here we drag the item number here. And then notice there's no loop expression because this is just a normal element. It's the first element in the loop. And if we run it, now we see we get the correct values. And you can do this as many times as you want. So if you want, say you want the first two elements of the loop to be, to be a certain thing, you can map it. You can do, you can map it that way. So that if you run, we see that. Now the other thing you can do is, and in this case, the actual loop remains, but since nothing is mapped to it and there's no loop expression, then nothing will be emitted. So it's safe to have that be there. The other thing you can do also is you can split a loop. So suppose that you have two. You have a loop that takes two input loops, and I don't have a good example of that here. But if you use the split loop function, it simply splits the loop into two, and then you can map them as if they're two different loops. So you can figure out the applications for that. Okay, now we're going to have a look at the case where the input is looping and the output is not looping. So in this case, you have to use some kind of aggregate function because you're either going to select something from a loop, or select many things from the loop, or you're going to do aggregation, which would be counting something or summing something or averaging, so forth. So we'll look at we're going to look at the counting example first. So we want to know the total items, for example, that we're going to in our output. So what we'll do is to do that we will use an aggregate function. We'll use the aggregate count function here, and when you specify a map element to the aggregate count function, so we want to count the items, so we drag that there, and what will happen is with an aggregate function, the loop expression is part of each argument of the function. So an aggregate function can have any number of arguments, and every argument has its own loop expression. This loop expression argument is exactly the same, it behaves exactly the same way that the loop tab does for a looping output element. So it describes the loop that's used to provide the context for this item. So you can do anything in the way of filtering or whatever you want to specify which item or which single item is the one that you want to select, or actually which items. You can select multiple items. So in this case, and it will also try to generate it for you automatically, just as it would in the loop tab. So in this case, what it's generating is probably not going to work, because what it's generated is a series of nested loops going all the way up to the purchase order. So what you're going to get here is all the items that occur over all purchase orders and deliveries, not just the one belonging to the purchase order in question. So if we run this, then the total items count you see is 6 and not 2 as we would expect. So what we have to do then is just fix this loop expression, because we only want the items that are inside of a given notice, and the notice is defined by purchase order and delivery. So what we can do is fix this loop expression. We can get rid of these extra nested contexts, and we can change the input map element here to just be the items. So now what it's going to do is it's going to consider only the items, and it's going to do them, if you don't specify any further context, it always uses the context of the enclosing loop. So, and the enclosing loop in this case is delivery and PO. So now we should get only every item within delivery and PO. So now if we run it, we should see that the number of items is 2 in each case, which is what we want. So, so that's an example of using an aggregate count function. Now there's another way we can use it. So let's now specify that we want the total notices. So we want to find out how many notices have been written. So again, we'll use an aggregate count function to do that. But we want to reference the notices in the output. So we don't want to have to figure out that notices came from something in the input. Let's just reference notices from the output. So you can, when you map, you can use you can reference output map elements from the value of an output element can be another output element, and the same way you can also reference output elements in your loops. So what it did was it generated a loop expression for us in this case, and in this case what it used is a special loop function called the loop copy function. So the loop copy function, if we look at the definition of it, it copies the loop expression from the specified output map elements loop expression. So what it did was, this is exactly the same as if we had this simple loop expression here. If we put this simple loop expression right here where this loop copy was, it would function exactly the same. So loop copy is basically saying use the loop that it refers to in this output element. So it's looking at the output element notices and using exactly that loop expression. And then if we run it, we should get the we should see that the total notices, okay, we have 0. So something, and it looks like it's giving us some warning. Oh, so this refers to an output element that has an empty value expression. So we probably want to say, instead of using the output notice, let's try referring to the number. Let's count these numbers here. There we go. So it looks like the aggregate count when used for an output, it should allow you to do it to the looping output element. So that's probably that's probably a bug. But here, if we just use some non-looping thing, it will look at the enclosing looping for both the loop copy and the for the loop copy and for the field that you want. Okay, now we're going to show the other example of aggregate looping, which is where we want to look at something inside of a loop of different values. And the best way to show this is EDI. So here we have, I've made a copy of the X125010 HIPAA examples, and I'm showing a map which maps EDI into a simple XML file. This is a response to a X12-271 transaction, which is a transaction that tells you the eligibility for benefits. So if we run the map here, it will provide this simple XML file that matches up with this EDI file. So you can see a sender and receiver are not in a loop, and a subscriber, it is a loop, and then it has some dependence. And if we look at the input, we can see this is what the EDI looks like. Those of you who have not seen EDI. So now what we're going to do is we're going to add a field to this output here. We're going to get some additional information. So if we go look at the birth date mapping here, we can, if you double click on the line, what it will do is it will take you to both sides of the, it'll make sure that both sides of the mapping are visible. So in this case, the birth date comes from this DMG02 element, which is in this DMG segment, which is in a loop corresponding to the subscriber name. So we know also that here there's a subscriber date. So if we look, we can show this single element, and this DTP segment here provides the date for this subscriber. It's a date range. So let's say that we want to get this subscriber date information out. So first of all, we need to have a place to put it, and this goes a little bit beyond looping, but I'll show you how you can change the structure and how the map adjusts to it. So we want to put it in the subscriber record here. So let's go over to the structure editor at the birth date, and we'll add a new element here. Let's say subscriber date, and we'll make it a date. So change the properties to editable. Its data type is a date, which is the default data type. It's fine. Oops. And we'll also move it up higher. Move it under birth date. Sometimes drag and drop is a little funny, so just cut it. Paste it as a sibling. So there it goes right under birth date. That's what we want to have. Okay, so now we save the structure, and after having saved the structure, we'll open the map editor. It's taking so long to save it. Now we'll go open the map editor, and what's happening now is that when you open the map editor, it's detected that something changed in the underlying structure, and it's giving you a warning indicating that happened. So here it's saying a new element's been added to the structure. It gives you links to the element, so you can go to the element, and the element's marked with a little star there, indicating that it's a new element. So and the same thing will happen if the element's been deleted. It will still appear in the map, but it will have a different marking, and that's so that you can keep the mapping instructions even if they've been removed to the structure, so that you can relocate them elsewhere. That'll be covered in another tutorial on mapping refactoring. So here what we want to do is we want to map this subscriber date to a value that comes from this loop, but we want a particular value because this loop here of subscriber dates could conceivably have multiple values. It happens to only have one in this document, but we want to only look for the one that we're interested in. So we want to do a an aggregate copy, aggregate cat. Oops, I'm in the right place for that. Just select the subscriber right here. Okay, so aggregate cat, and we want to get okay, now this is a date time period, and we actually have some special support in that we understand EDI, and in the date time period we will populate these sub items here of the date and the end date, and you can also get the whole value as a string. So we will parse that out, and it understands the different kinds of format qualifiers and so forth. So that's all kind of built into the EDI support. You don't have to worry about it. So what we just want is the date, and so that's what we want. Now what it's done is first of all, it's indicated that it's now mapped, so this new element warning will go away. And as before, it automatically generated an aggregate, a loop expression, which actually takes it all the way back up to the top level loop. Actually, this particular type of automatic expression generation is probably not what we want to do. We'll probably change the product to only have it generate what I'm going to end up changing it to, because that's the more common case. So in this case, it's going to look at essentially all of these DTP elements in any of these loops. So it'll look at all of them for the entire document, which again is not typically what you want. So we'll get rid of all of the nested contexts here, and we'll change the element that we're looking at, because we only want to look at the ones, we only want to look at the loop that is inside of the loop here, the subscriber loop that we're referring to. So now we've changed it to be that, and so now if we run it, we should see, okay, so we're not seeing the subscriber date, and we're getting some kind of warning. So it's not able to convert a string to a date. Now the reason why is because this date here is probably a date time. Yeah, so this is a date time, and it's trying to convert that to a date. So what we want to do is fix the output of this then is going to be a date time, and we want to change that into a date. So we have some date functions that we can use to do that. We can say extract from date time. Now here's a trick that I'm going to show you that if you want to, we don't want to lose what we've done here, this aggregate cat, but we need to put something as its parent. So what we can do is we can cut it, and we can put it over in the validate tab, and just for sort of temporary storage. So we'll say extract from date time, and now we'll cut it out of the validate tab, and we'll paste it here. So that's a quick way of sort of adding, of sticking something as the parent. And what we're going to extract from the date time, it's already telling us is the date. That's the default. If you double click on it, there's a property that says what do you want to extract. So you can extract any number of things from the date time, but the typical case is the date. Alright, so now if we run it, we probably, yeah, so we see the subscriber date correctly. So it got the right thing, and notice that there's no more warning. However, we're not done, because, well, the way this loop is structured is it's going to take every value of this DTP and it's going to concatenate them together. And we really don't want that, because in this DTP value here has a qualifier. So there's any number, you know, there's all kinds of things about what is the meaning of this date. And what we want is the eligibility date. Because if we look at the actual value we have in the document, it's a 307. So that's the one we want. So what we need to do And also, just here's another little trick here. Say we wanted the eligibility date, and I mean, these code lists can be extremely long. This one's a short one. But say we wanted to just find, we knew it was eligibility. So what we can do, if you click on an element in any kind of tree in the product, and you just type some characters, those characters act as a filter. So, you know, you type ELI, for example, and it will filter by that value. And then if you hit, you can backspace to remove the filters, or you can hit escape to delete the filter entirely. So what we want to do is we want to add a filter for the value of 307. So if we go back into our loop expression, and remember the filters are down here in the loop expression, so we want to say we want it to be equal, and we want the date time qualifier, and we want it to be equal to 307. So notice I just drug the value down here and it made a constant function for me. So now we should get the same output. Because there's only a 307 in here, but let's just test it a little bit. So let's just change the value of the constant to something, you know, something different. And now if we run it, we see the subscriber date doesn't appear because it's well, it's actually giving, and it's giving an error because it's trying to convert an empty string into a date time. So because it didn't find anything there. And there's a way you can suppress it, suppress the element if there's no value, but I'm not going to go into that now. So we'll change it here. So this is a very common case, particularly in EDI, where you want to have your output be a value that comes from some looping element here, and you want to select a particular instance of that loop based on a qualifier. And this is how you do it. You use the aggregate concat function, and you use a loop, and then you use this filter. And as we can see, it finds the right subscriber date. So the last part of the tutorial, I'm not going to do any further. There are some other looping functions that are available, but they're for more complicated situations. And I think once you've gone through this part of it and understood how the basics of looping works, and if you refer to the documentation, then you'll probably be able to work out the more complex looping situations on your own. So the ones that I'll just briefly mention them as soon as the help gets reloaded here. So we've gone through the simple and all that. There's an example for merging two loops into one, and that example, one of them loops the address loops, and then you use an aggregate function as shown here to pull out the corresponding additional information from the second loop. You can work that out. There's recursive looping. So in a bill of materials situation or something where you have recursion on the input side, you can specify for the output side that you want the corresponding recursion, and you use a different loop function for that. You use the recursive loop function. And then there's another situation where you may have, for example, recursion on the input side, and you want to flatten it out, and there's a special loop function that deals with that. So you can look through the examples to work that out, and you can also look through the the help of the different loop functions. There's also an index range loop, which is a sort of a special loop where you want to pull values out of a loop for a given index range, which is a useful thing in EDI. So this concludes the looping tutorial.